Welcome to aminacademy.com. In engineering economics, let us discuss about different interest formula and its explanation. First one, equal payment series sinking fund. That means in this type of investment mode, the objective is to find the equivalent amount A that should be deposited at the end of every interest period for n interest periods to realize the future sum F at the end of the nth interest period at an interest rate I. Look at here figure. This interest period starting 0, 1, 2, 3 up to n periods and A equal amount A and percentage. I percentage is figure every year it's accumulate and get this final future values and starting point here. Cash flow diagram is like here. A is equal amount to be deposited at the end of the each interest period. You have to calculate A for each period how much you have to pay. N is number of interest periods, I is rate of interest, F is single feature amount at the end of nth period. Single feature amount you can get after using accumulation of these things. Where here that factor A over F comma I comma N is called equal payment series sinking fund factor. That means you have to find this factor and multiply with this given amount of investment and you can get it. Look at here. Here the given data is N equal to 12 years. Look at this example. A company has to replace a present facility after 12 years at an outlay of 4 lakh rupees 4 lakh. It plans to deposit an equal amount at the end of every year for the next 12 years at an interest rate of 16% compounded annually. Find the equivalent amount that must be deposited at the end of every year for the next 12 years. Look at here. The given data equal to N equal to 12 years, F equal to 4 lakhs, final future value is rupees 4 lakh, I is interest rate is 16%. To find A means equal amount to be deposited every year at the end of every year you have to find. Now look at this formula. N equal number of interest periods, I equal to rate of interest, F is single feature amount at the end of nth period. Look at this. This is a formula. A equal F into I over 1 plus I into power n minus 1, that is FA. F into A over F, I n is a interest factor. Equal payment series sinking fund factor you have to calculate. Look at this example, you can understand this formula now. A company has to replace present facility after 12 years at an outlay of 4 lakh rupees 4 lakh. It plans to deposit an equal amount at the end of every year for the next 12 years at an interest rate of 16% compounded annually. Find the equivalent amount that must be deposited at the end of every year for the next 12 years. Look at this given data. N equal to 12 years, F equal to rupees 4 lakhs, I equal to 16%. To find A. Look at this factor, AF. Interest factor you have to find. AFIN. Look at here, which is equal I over 1 plus I power n minus 1 equal I is 16%, that is 0.16 over 0.16 power 12 minus 1. Here this 0.16 over you have to calculate the power by using scientific calculator. 1.1 over 6 power 12 is and minus 1 is this 4.936. Then division 0.16 over 4.936 is this. This is called a interest factor. Which interest factor? Equal payment series sinking fund factor. Now we have to find the value of A equal to 4 lakhs into this interest factor, that is 40 lakh into 0.0324, calculate by using this formula and multiply, we can get A equal to rupees 12,960. The company should deposit an equal amount of rupees 12,960 at the end of every year for the next 12 years at an interest rate of rupees 60,000 to get an outlay of 4 lakhs. Next example problem, look at here. On uniform gradient series annual equivalent fund, this another method. A person would like to invest rupees 2,500 at the end of the first year, and thereafter he wishes to deposit the amount with an annual increase of rupees 500 for the following 14 years with an interest rate of rupees 8%. Find the total amount at the end of the 15th year of the above series. Look at here. For first year, he has to pay 2,500. From the rest of the years, the increase of 500, that is 3,000 he has to pay for the next 14 years. This is a combination of first year some different amount, and from the second year onward is the another different amount, that is 2,000 adding 500 more. In this situation, look at this, the given things. A1, first investment is 2,500. G, second investment is rupees 500. N equal to 15 years. I equal to 8%. To find F and A, future amount and equal amounts you have to pay. Formula used is equal here, F equal to A into F over A IN. This factor you have to calculate by using the formula. Look at this formula. In this situation, the formula is 1 plus I whole power n minus in minus 1 over I into 1 plus I power n minus I. Using the values, 1 plus I is 1.08 because 8% power 15 minus 0.08 into 15 minus 1, which is equal 0.972 over this calculation. Look at here, I into 1 plus I all power n minus I is 0.08. This here 0.174. This calculation gives 5.594. This is the interest factor. Now we have to use the A equation is A equal to A1 G into A slash GIN. That is, first investment is 2,500. Rest of equal amount is 500 into this interest factor. That is 2,500 plus 500 into interest factor is, we calculated 5.594, which is the amount A, 5,297.25. The future sum of the rupees 5,297.25 at the end of 15 years is, further you have to calculate future amount equal to A into F over A IN 5,297.25. This further you have to calculate this interest factor by using the same way of 8% 15 years. Further, this amount we have to calculate. For this amount you have to calculate. In this we can get it 27.152 is the new factor. That factor is multiplied with this one. So we'll get F equal to future value is 1,43,830.932 amount, the rupees. The result, the total amount received by a person who invests rupees 2,500 at the end of the first year and deposit the amount with an annual increase of 500 rupees for the following 14 years. That means annual increase. Every year has to increase the amount 500 more and more. That means for second year 5,500 more, third year 1,000 more, 1,500 more like. Then we can get 1,43,830.932 rupees at the end of 15th year. Now, effective interest rate and nominal interest rate. An interest rate takes two forms: nominal interest rate and effective interest rate. The nominal interest rate does not take into account the compounding period. The effective interest rate does take the compounding period into account, and this is a more accurate measure of interest charges. That means nominal interest rate means formally at end of each year the compound interest is calculated, but effective interest rate is maybe it is calculated every half of the year, that is 6 months, every 4 months, every 3 months, even in every month. By calculation, by using this fractional method, that is even every month, that is more accurate interest rate we can calculate. Look at this example. What is the nominal rate of interest on a company that has 7.77% rate of effective interest annually around two decimal places? Look at here. First, which is given, M equals 12, that is 12 months per year. M value is 12 because suppose each month interest is calculated. I is 7.77 percentage. Now effective interest formula, which is equal here now 0.0777. Effective interest formula. Effective interest formula is I equal, that it is 1 plus j over m power m minus 1. Now, nominal interest rate is given, that is equal 0. Here, nominal interest rate is given, we have to find the effective interest rate. 0.077 is the nominal interest rate, equal 1 plus j is effective interest rate we have to calculate by 12, because every month it's calculated. For 1 year it's 12 months, minus over 12 minus 1. Now this one come this side, that is 0.0777 plus 1 equal 1 plus j over 12 over 12. Now this 12 over 12 comes in the root, which is equal 12th root of 1.0777 equal 1 plus j over 12, which is equal, this minus from this side, 12th root of 1.0 1.0777 minus 1 equal j over 12. This one on this side. Then j equal 12 into this 12 come one up here. 12th root of 1.077 minus 1 equal. Then by using calculator, you have to calculate 12th root of 1.0777 and j value. By using calculator, you get it approximately 0.0751. Therefore, nominal rate of interest is equal j equal 7.51%. From effective interest rate, we calculated nominal interest rate. Here, this is effective interest rate. So this is effective interest rate. Effective interest rate of interest is j equal and nominal interest rate. Nominal interest rate equal to 7.77% already given. So it is more accurate. It is effective interest is 7.51. Nominal interest rate is 7.77. We have done. Please subscribe our YouTube channel.